Hello all. So in last couple of lectures, we have seen this problem already in detail, and we have seen all kind of recursion, which is Boolean based recursion and also non-type recursion. Okay, and we have seen an important difference in conditional recursion as well. That how can we avoid unnecessary calls if we find the breach? And we have used the in-order traversal for this. Okay, so in order, it's like firstly we process the left node, and then firstly so it's left node is processed and then comes to the root, and then we process the right node. And obviously we have done some conditional recursion, that's why you can see all the comments here, and we have discussed in thorough detail with all the print statements that how the recursion works. So we have studied recursion using this problem. Okay, and we have seen in thorough detail, but now it's a time for another method, any other method that we can solve, because in interviews we need to solve with all possible methods, because interviewer might ask any other method that you can solve. And if even he didn't ask, you should tell all the methods that you know along with their space and time complexity. Okay, so let's see any other method that we can uh, apply here. Okay, so here is again a binary tree, again a random binary tree that I drawn, but now we will be using the ranges. Okay, so each node we know that this can lie from minus infinity to plus infinity. Okay, but for this node, the constraint will be from minus infinity until 15. Obviously 15 not included. So if it's equal, we will say it's false. Okay. Then this should lie again minus infinity as the lower limit, but upper limit should be 10. Okay. Obviously less than 10. And then here, what will be the case? The lower limit should be 10, but the upper limit should be 15. Correct. So it should lie between this. Obviously 10 and 15 both not included. Similarly here, obviously right side will be my until plus infinity, but on the left you should start greater than 15. Okay, so it should be between this range. Similarly for this node, what can be the potential range? So obviously the upper limit should be 20 and the lower limit should be 15. Correct. And here obviously the upper limit should be plus infinity, but the lower limit should be 15. Correct. Or it should be 20. Correct, because it should be greater than 20, not 15. Okay, so it should be greater than 20. Now there is an important observation that we have to observe here, that for left recursive calls, you can see for left calls, the lower limit remains the same. What I mean by remains the same, it remains same as the previous one. So remains same as of its parent. So for 10, the lower limit remains the same as of its parent, which is 15. For this node 5, its lower limit remains the same as of its previous one. Okay, just its previous one. Okay, don't consider it will be same for all. Okay, but the upper limit changes. Correct, upper limit is what it changes, but it's what it's same as its parent. You can see this node has upper limit same as its parent. So let me write that observation, that for left calls, lower limit is same as its parent, or it's like parent better. And let's see now the right side call. And what happens to the right side call? There was one right call here. So you can notice that upper limit remains the same. You can see for the right side calls, the upper limit remains same as previous. You can see this is the right side call, upper limits remain the same. So for the right side call, we will say my upper limit remains the same as its parent. But the lower limit changes. You can see lower limit changes, but it's same as its parent. Here as well, the lower limit changes, but it's same as its parent. Okay, so this was the left call, correct? So lower limit remains the same, okay, as same as its parent, but the upper limit for the left call changes and it's same as its parent. But for the right call, you can see the upper limit remains the same and the lower limit is same as its parent. Correct. So that's what we have to incorporate, and here we have to pass this min and max. So we will always have min and max as a variable in our recursion function, so which will be a local variable. So along with the root, we will have two more variables. So here we just pass the root, right, in our recursive function or the in order function. But here what we will do is, along with the root, here we will call it helper function rather than calling in order, because we are not doing in order. But we can put it like as an in order as well, but we will see that it works for all the cases. But let me just remove it, and let's try to write everything from scratch. So okay, this is the same code, but it's with the boolean type, but ignore it as of now. I'll just write everything from scratch. So firstly, we'll use the return type as none, and let's have our helper function. Right now I'm calling it a helper function, and there will be a flag which will be true by default, and our helper function will make it false if the condition is breached. Okay, that is, what's the condition? That it should fall in that range. Each node should fall in particular range. If that's not the case, we will just return, or we can say we will set this flag as false, and then at the end we return. Okay, but here we will need first the root, and obviously we have seen that the root has the entire range. So it starts from minus infinity, should be in the quotes, and goes until plus infinity. So minus infinity, and let's have plus infinity. Okay, and obviously we will return our flag. It's made false. Now let's write this helper function. Should take root. So let's take root, and let's take minimum. Min is a keyword, so we can't use it. So let's have mini, let's have maxi. And what should be the return type? It should be none. Correct? Obviously, we will have the base case and the logic, and we write logic first. So firstly, we will go for left recursive call. So we will go for root dot left, and obviously, firstly we have to check whether our range lies. I mean, we will see that. That's the important part of this lecture. But let's check the mini. So as I said, for the left, the lower limit remains the same. We have noted that it's a bit confusing or tongue twister sometimes to lost this plot. So lower limit remains the same for the black. Sorry, for the left. So, and upper limit is same as the root value. So please mind it that we are going here to the left side from the root. So firstly, for example, we were here. We are now calling the left side. We are going this, but root is still here. Root dot left obviously will be this, but root is still here. So we are comparing now that for node 1, the lower limit is still minus infinity. It remains the same, but my upper limit has now changed, okay, to the root value, which is this, correct? And similarly, I have discussed in thorough detail with the call stack, showing the entire call stack, okay, in my previous videos on the same problem. So please check it out. It's the best video to understand recursion, because recursion is the most confusing topic. Okay, and now here the max should be the same, because we have seen that for the right recursive calls, the upper limit should be same as its parent, but the lower limit should change. And what it should be same as the root value. But the most important part, we have to check that if my value of root, if it's greater than or equals to the max, or my root dot value is less than or equals to mini, okay, then we will make our flag as false, correct? And obviously, not to forget the base case. So if my root is none, we will simply return. correct? Let's try to run this. Obviously you have to remove this to run this. So let's remove this as of now, and let's run. We'll run the last one. Okay, I forgot one parenthesis. Perfect, it's working. Let's submit. Obviously the space and time complexity remains the same because we are visiting all the nodes, and space will be also the recursive stack space, so it should be the height of the tree at the end. So space and time doesn't change, but that's how it works. So now my question is, please be honest in answering yourself. If I put this logic here and run, will it work? Yes, it will. Let's see. Even if I put this on the way top, it will take a while to sync this logic in. It will still work. So it's like whether we are processing the root, like, so whether we are doing pre-order traversal or in-order traversal or post-order traversal. Okay, it doesn't matter in this case. Why? Because at the end, we have to check for this condition. Okay, so what this means, right now we are processing root first. So what does this mean? This means that we are first checking whether our 2 lies between this range of minus infinity and plus infinity. Okay, if it's not, then okay, we are first checking for this node. Okay, if I put this, okay, if I put this in between, then I am checking for this node later on. Okay, I'm not checking it at first. Okay, so it's like in order. So firstly I'll process the left side. I'll check for the left first. So I'll check for the range of lefts, and then I'll check for range for this, and then I'll check for range for this. So it's just what the order changes if I put this above or in between or below. Okay, so that's the really simple thing, that wherever I put, it doesn't matter. Why? Because at the end you have to check. Let's dry run for one this case of in order. So here what will happen is, firstly we are telling it to go to the left. Firstly it will go to the left. Okay, let's have the stack. It will be perfect to have a stack, and let's have just the simple example of 213. Okay, and it's a BST. Let's have the stack. So firstly, obviously what will happen, our helper of root. So what is root? Root is 2. Sorry, we start with 2 and we have minus infinity and plus infinity. Okay, then this will be called. Okay, first this will be called from here, and it will check if its root is none. No, it's not none. So it will go and hit this condition. So it will go to root dot left. So let's go to root dot left, which is here. Okay, it didn't check anything because the checking condition is later on. Okay, so it will check later. Firstly it will go to the left. So what is at left of 2? Left of 2 is 1. Okay, and now what will change? As I said, the lower limit remains the same, which is same as minus infinity. Okay, so you can see the minimum, whatever minimum we came with, okay, here it will remain the same, but the upper limit will change. What will be the upper limit? It will be the root value. Okay, so what was the root value here? 2. So it will be changed to root dot value. Okay, the star indicates the entire node, where this just 2 indicates it's a value. Okay, now it will go here. Now again we will check this condition hits here, and again we will check whether the root is none. No, it's not. And again we are hitting here root dot left, and we now know that my root dot left is none because it has none. Correct. So it will hit the base condition, not to write, but let's write that it's hitting none, and it doesn't matter whatever is here. So obviously it will be minus infinity, because at the left call the lower limit remains the same and upper limit will be 1. But doesn't matter because it will hit the base case, that if my root is none, just simply return to the place from where it was called. So now it will go to this place. Okay, now it comes to this for the first time. Obviously the popping happens, so let me pop. So since the return statement was hit, this will happen, and now the control is again back to, from this the control is back to 1. Okay, because now you can see on our top of the call stack it's 1. Now, again, obviously, after this, now the condition will be checked. And what will be checked? That 1 should lie between minus infinity and 2. Is it lying? That will be checked. You can see here it will be checked. What is max? Max is 2 here, correct? So it will check whether my 1 is greater than 2. No, it's not. So this is not satisfied. And it will check whether it's less than minimum. Is my 1 is less than minus infinity? No, it's not. So firstly, you can see we have checked for this, the range. And that's why it's called in order, that we are going for firstly on the left and then root and then right. Okay. That's why it's called in order, that firstly we'll go to the left. In pre-order, firstly we'll check for root. So here for this node, it's being checked now. Okay, so we will check. And now after the check is being done, okay, it's not satisfied. So flag is still true, correct? And now we will hit this root dot right. And now the root dot right is obviously none. Okay, so again, it will be hitting the base case. So it will be again, there will be none here, and again hitting the base case return. So I'm just not writing it. It will pop out, and the both the calls of 1 are done. Okay, so now 1 will be popped out from the call stack because we are done. And since 1 was the left recursive call, so we will hit to this place again. And now who is on the top of the stack? It's 2. Okay, so now 2 is on the top of the stack, correct? So now we will check for 2 that it's done. We will return here, and now we will check for 2 that whether it lies between minus infinity and plus infinity. Yes, it's lying, so this condition won't be hitting. And now we will go to the right part. So now even for 2 is being checked. That's why it's in order. You can see root is in between. First we will check for left, then we will check for root, and then we'll check for right side. Okay, so now for 2 it's being checked, and now we will go to this side. Okay, so now it will hit from this, it will go to the right side. That for this also checked, that 2 is done, and now it's time for 2 dot right, which is 3. So now it will hit, let me write, now it will have helper of 2 dot right, which is 3. And for the right call, what happens is the upper limit remains the same, but lower limit will become the equals to the previous root value, correct? Now this will be on the top of the call stack, okay, because this was called. Now we will see if it's none. No, it's not none. So we will again come here. Now we'll go to left side of our 3, which is none. Here it's none, right? So again, the same thing that happened for 2, it will happen. And we will check that, okay, no, left is none. So we'll directly return here. Now we are returning to the mid, which is root. So now again, we will check whether 3 lies between the specified range of 2 and plus infinity. Yes, 3 lies in between 2 and plus infinity. So this will be also checked. And now we will go to right side. And also it will be hitting none. So it will be popped out. Okay, so both calls of 3 are done. It will be popped out. And now we will return to 2. And both calls of 2 are done. So it will be popped out. And we are done. Correct? So recursive stack is empty. So that's how the entire flow works. So that's why it doesn't matter whether we put this here or above or below. It's all the same. So that was the reason to make this video. It will take a while to sink in a bit, I know, because it's recursion, but if you do it consistently, you will figure out that recursion is the easiest topic ever. Okay, so stay tuned and thank you.